Okay, man, this is so much fun. So let's look at 15. 15 is lefties redux. Redo. Consider our group of 5 people from exercise 3. How many lefties do you expect? Okay, how many lefties do you expect, which means the expected value. Expected value is also known as the mean. So if I've got 5, and I expect to have a probability of 13. Expected value is n times p for a binomial distribution. N times p, 5 times 0.13. 5 times 0.13. And I expect to have 0.65 lefties. Ah, that went away. 0.65 lefties. What is a standard deviation? Standard deviation for a binomial distribution is the square root of n times p times 1 minus p. This is on the formula sheet, so it's not that big an issue. Square root of n is 5, p is 0.13, 1 minus p is 0.87. Second square root, 5 times 0.13 times 0.87. I don't need to close the parentheses because it will automatically do that, and I get a value of 0.7519, or because we're going to 2 places, 0.75. If we keep picking people until we find a lefty, how long do you expect it to take? All right, so I'm going to keep going until I get 1 lefty. How many people is it going to take? Again, I'm going to do n times p is equal to, but what's my expected value going to be? It's going to be 1. Now, this is geometric mean, okay? That's exactly what this is, but I'm going to set my expected value at 1. So, n times p, I'm looking for n, 0.13 is equal to 1. So, n here is equal to 1 divided by 0.13, and 1 divided by 0.13. 7.69 people until I get a lefty. Man, you know what? We're really good at this. All right. All right, so let's take a look at 17. 17 says still more lefties. Suppose we choose 12 people instead of the 5 chosen in exercise 13. A, find the mean and standard deviation of the number of right-handers in the group. Okay. So now what we've done is we've increased the sample size from 12 or from 5 to 12. So n is going to be 12, and we're talking about right-handers. So the probability of success is now 0.87. Find the mean and standard deviation. Okay, mean is n times p, which would be 12 times 0.87. Standard deviation would be the square root of n times p times 1 minus p, which would be the square root of 12 times 0.87 times 0.13. Now, what's interesting here is that this standard deviation is going to be the same whether it's for whether it's for righties or lefties, because this is a standard deviation for righties, but the standard deviation for lefties would be 0.13 times 0.87, and you know the associative, or not associative, commutative property of multiplication says I can flip these. And that's fine. So I'm going to get the same standard deviations whether we're talking about righties or lefties. B, what's the probability they're not all right-handed? Okay, probability they're not all right-handed would mean that I've got some lefties, okay, or at least 1 lefty, and at least 1 would be the complement of none. But that's it even implies that what's the probability that they're not all right-handed? That would be the complement that they are all right-handed. So what's the probability that they're all right-handed? Well, the probability that they're all right-handed would be 0.87 to the 12th power. But I should actually think about this, setting this up as a binomial formula. Because what I have is I have 12, choose 0. And then I've got 0.87 to the 12th power times 0.13 to the 0 power. Now, if we think about this, how many ways can I have 12 and have 0 successes? That answer is actually 1, okay? Times 0.87 to the 12th power times anything to the 0 power is 1. So actually what I have is 0.87 to the 12th power, which is fine, but that's your answer, 0.87 12th power. Final answer here, Regis, is, do I have this problem somewhere? I don't know. Apparently I don't have it written down. Okay. Then how would we bring it to calculator? 0.87 to the 12th is 0.1880. So 1 minus that, because it's the probability they're all right-handed, and we're looking for the probability that some are right-handed. So 1 minus that is going to be 0.8120. Yep. Okay. C. What's the probability there are no more than 10 righties? Okay. No more than 10. So we're talking about a bunch of righties here. So here's what I'm going to do. I'm going to write down. I could have 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9 or 10 or 11 or 12. That's going to, it's awkward. It's going to be helpful. No more than 10. So what does that mean? That means 10 or less. I'm looking for this group. 10 or less. All right, what do I have to write? I have to write the binomial formula for the first and the last. I have 12. 12, I'm going to choose 0. Probability of success, 0.87. How many successes? 0. Probability of failure, 0.13. How many failures? 12. Plus, dot, dot, dot. Plus, last one. 12, choose 10. 0.87 to the 10th. 0.13. If I have 10 successes, how many failures do I have? 2. Okay. So here's my dividing line. Right there. I'm going to do binomial CDF to get this value. And then I ask myself, do I want this group or do I want the group to the right? And the answer is this group. So when I do the binomial CDF, this is going to be my final answer. So, second distribution, binomial CDF. Enter binomial CDF. N is 12, comma, 0.87, comma, how many successes? 10, and I get an answer of 0.4748. This is easy. What's the probability that a majority is, D. What's the probability there are exactly 6 of each? All right. So exactly 6 of each, which means I'm looking for the probability of having exactly 6 right-handed. Okay? Because if I have exactly 6 right-handed, I have exactly 6 left-handed. So, again, probability of 6 right-handed equals 0.87, and I'm looking for exactly 6. This is binomial. I'd say, oh, I've got 12, I want 6. 0.87 to the 6th, 0.13 if I have 6 successes, I have 6 failures. So I do this. But notice this is what's really interesting. If I do this as being 6 left-handers, it would be 12 choose 6, 0.13 to the 6th. Failure would be 0.87 to the 6th. I'm going to get the same value. You can do that. Binomial PDF for 6. What's the probability that the majority is right-handed? Okay, so what does that mean? That means that if we're talking about the majority, think about this. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, or 12. What's the majority? Majority is that I have to have 7 or more. So we're looking for this group. Because if I have 7, I have majority. If I have 8, I have a majority. 9 majority, 10 majority, 11 majority, 12 majority. If I have these, I have a majority. Okay? So I'm looking for this group. Where's the dividing line? The dividing line is right there. Okay. What do I have to write? Because I'm looking for this group, I'd say I'm looking for 12 choose 7 times 0.87 to the 7th power times 0.13 to the 5th power. 12 minus 7 is 5. Plus dot 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 plus 12 choose 12 for the last one. 0.87 to the 12th. 0.13 to the 0. Okay, that's what I have to write. How do I find it? Well, there's my dividing line. So, I'm going to, and I always have to find the lower group. So I find a lower group using binomial CDF. CDF of what? CDF of 6. Is that my final answer? And the answer is no, because I want the group to the right. So it's 1 minus whatever I get with the binomial CDF. And we're probably out of time on this one, so we're going to stop there.